To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Right, children. Now we are going to start the exercise chapter of this lesson. So as I told you all before you watch this one, you all have to do all the exercises, all the questions by yourselves. So then when I explain you all, you can check whether your answers are correct or not. So in that case, you know what are the parts that you did not understand, and you can go through those parts and try to do the same questions again, right? So we are going to start with the exercise given in the textbook first. Right. Look at the first question. Chandrakanta comes to school by bus. Its horn has a high tone. There are electric bulbs to illuminate the bus. When the bus runs for a long time, the engine is heated. Right, children? So this is a small description. So questions given out of this description, okay? Write 4 forms of energy you identified in the bus. So now you all know there are different forms of energy that we can use in our day-to-day lives, right? So in this one, what are the different forms of energies? We will go through this again. Chandrakanta comes to school by bus. Its horn has a high tone, which means sound energy. Let's write it first. Right. So high tone means sound energy. Right? There are electric bulbs. Electric bulbs means electrical energy. Electrical energy. Electrical energy. Right? Okay. Electric bulbs to illuminate the bus. Illuminate means light up, which means light energy. Right? When the bus runs, kinetic energy, for a long time, the engine is heated. Heat energy or thermal energy. So we can write one of those things because we are asked to write only 4 forms, right? We will write heat energy. Heat energy. Right, children? Sound energy, electrical energy, light energy, heat energy. Right? You can even write kinetic energy. Bus runs means bus moves, okay? So you can even write that one if you want, okay? Here the question asks only 4 forms of energy, right? We'll move on to the next. Right. Next one. What is the basic form of energy used for generation of various forms of energy in the bus? What is the basic form of energy, children? You all know the vehicle, when you consider of any vehicle, it runs because of its battery. Right, children? If the battery does not work, we can't even start the vehicle. So in that case, what is the basic energy is used? You all know that all the batteries are considered as chemical cells. Right? Cells and batteries generate electricity because of chemical reactions. So there what happens? Because of chemical reactions, electrical energy is generated. Okay, so chemical energy is converted to electrical energy. Right, children? Therefore, what is the basic form of energy used for generation of various forms of energy? All the other types of energy can be formed if we start the bus. So in order to start the bus, the battery must work. Right? So the battery contains chemical substances. You all know that when it comes to vehicle batteries, we call them lead acid accumulators. Why do we call it lead acid accumulators? Because they contain dilute sulfuric acid and lead plates. Okay, so those are chemical substances, right? So what is the basic form of energy used for generation of various forms of energy in the bus? Chemical energy. Chemical energy. Right, children? So number 3, list out 3 uses of each form of energy you mentioned above. Right? So here we mentioned different forms of energy: sound energy, electrical energy, light energy, heat energy. So when we were discussing these forms of energy in the lesson, we all discussed what are the uses of each forms of energy. So I hope you all have done this part correctly. Right? So first let's take sound energy. What are the uses of sound energy? Sound energy. Let's write, children. So now here, even though under this part they have asked you all to write down only 3 uses, when you do this one, try to write the other uses as well. So thereby you can practice more and more, okay? Right, sound energy. What are the uses of sound energy, children? Let's write. You all know sound is used for communication, day-to-day life communication. Right? Let's write that for communication. For communication, general communication, right? And you all know it's used in music industry. Music industry. Right? And at the same time, I told you all, ultrasound waves, a type of sound waves called ultrasound waves, they are used to treat patients, right? In medical field. In medical field. Right, children? What is the next one? So here we have to write 3 uses of each form of energy. But when you do that, you can keep on going with the list, because in that case, you can improve your knowledge, okay? Right. Second one, electrical energy. Now here you can write a long list for electrical energy. The uses, day-to-day life, we use electrical energy every single time, right? Let's write electrical energy. Electrical energy. Right. So what are the uses of electrical energy? You all know, to cook food, sometimes we use electrical cookers and ovens, right? So to wash clothes, we use washing machines, right? And to get wind or air, we use electrical fans, right? And we use electric iron to iron our clothes. We'll write some of them. To cook food, to iron clothes, to heat water, right? Okay, children? Next type of energy we mentioned here, light energy, and then heat energy, right? So first we will write light energy. Light energy. What are the uses of light energy, children? What is the main use of light energy that takes place in the environment? You all know photosynthesis process. Light energy is very important, right? And at the same time, light energy is used as signals in lighthouses and also in traffic lights. We use the light energy as signals, right? And at the same time, you all know different types of light rays as laser rays. They are used in medical field to treat patients, okay? Let's write light energy. And also light energy is used to illuminate, right? For decorations as well. We will write for photosynthesis. Photosynthesis. Solar panels can generate electricity using light energy, right? So to generate electricity. As signals. Right, children? And the last one, let's write heat energy. Heat energy. Heat energy also can be used to generate electricity in thermal power plants, right? Heat energy is necessary to cook food, to dry clothes, okay? Let's write. To generate electricity. To cook food. To dry wet clothes. Right, children? So sound energy is used for communication, in music industry, in medical field, right? Electrical energy is used to cook food, to iron clothes, to heat water, etc. Light energy for photosynthesis, to generate electricity as signals, okay? Heat energy to generate electricity, to cook food, to dry clothes. So as I told you all before, when you do this activity, try to make the list longer, okay? It's a good practice for you all. We'll move on to the next. Right. A table is given. Complete the table given below, right? So the first column mentions equipment. Second column, form of energy given to the equipment. Third column, other forms of energy generated in the equipment. I hope you all remember we did a similar activity in the lab as well, okay? So the first one, electric bulb. What are the forms of energy? What is the main form of energy given to the equipment? In order to light up, in order to make this electric bulb work, you have to provide electricity, therefore electrical energy. What are the other forms of energies produced when you use this bulb? Because of electricity, it produces light energy, and at the same time, after a little while, if you touch the surface of the bulb, you can feel that the surface is heated up, which means heat energy is also generated, right? Therefore, let's write this. Light energy and heat energy. Right, children? Second one, TV set. In order to turn on the TV, what do you need, children? You should provide electrical supply. Therefore, form of energy given to the equipment is again electrical energy. Electrical energy. Right. So what are the other forms of energy generated in the equipment? When we turn on the TV, sound is produced. Light is also produced. So in the same way, heat also produced. So after a little while, after about 10-15 minutes after turning on the TV, if you touch the back of the TV, you will feel that it's heated up, right? That's because of production of heat energy. But basically, light and sound energy is produced, okay? Right. Sound energy, light energy. Right, children? Next one, electric bell. Electric bell, you have to provide electricity and it produces sound energy, right? Electrical energy is converted to sound energy. Next one, wind-in clock. So in the wind-in clock, you all know that there's a wind-in key. Using a key, you have to wind the spring inside. Now you can't see the spring, but there's a key to wind up the spring which is present inside of the wind-in clock. So when you wind it up, what happens, children? So we can wind the spring closer to each other and thereby it stores potential energy. So when we release the key, what happens? That potential energy little by little is released into kinetic energy, right? So it starts to move. The arms of the clock starts to move because of the potential energy released by the spring. Because the arms move, we call it kinetic energy, right? So wind-in clock, form of energy given to the equipment is potential energy. Potential energy. And other forms of energy generated, kinetic energy. Sound energy is also produced because you all know that there's a ticking sound to the wind-in clock. So we can write that also, okay? Sound energy. Right, the last one, hydropower station. So in the hydropower station, you all know that the turbine is worked using the flow of water. So you all know that the water is initially stored at a higher elevation, right? And that water flows through canals and it reaches the turbine. It makes the turbine work or rotate, and as the turbine axis is connected to the dynamo, the magnet of the dynamo also rotates and thereby electricity is generated. So initially, here when you store it at the higher elevation, because of the location, it contains potential energy. Potential energy. And then when the water flows, the moving objects contain kinetic energy. So the water starts to flow and the potential energy contained in water is converted to the kinetic energy of water. And because of the kinetic energy of water, the turbine starts to rotate. Therefore, the kinetic energy of water converts to the kinetic energy of the turbine. So as it is connected to the magnet, then the kinetic energy of the turbine converted to the kinetic energy of the dynamo. And when the magnet of the dynamo rotates, the coil inside the dynamo can generate electricity. Therefore, kinetic energy converts to the electrical energy. So potential energy first converted. We can consider the kinetic energy of water and the turbine and the dynamo, everything together as kinetic energy, right? Kinetic energy and electrical energy. Right, children? So what is the main energy transformation? Potential energy into kinetic energy into electrical energy. So here the first one is given as kinetic energy of water, right? So kinetic energy of water is converted to, I told you all here, the kinetic energy of the turbine, right? Right. So let's write here. Kinetic energy of turbine. Right. So we have completed the exercise given in the textbook. I hope this was clear and I hope you all have done this correctly, right? So we have done so many examples of the same type of questions. Therefore, I hope you all have done this correctly. Even though we have completed the exercise given in the textbook, in order to practice your knowledge more and more, we are going to do some extra questions as well. We will start it now. Right. So additional exercise number 1. First question. Now here you have to underline the correct answer. Okay. Number 1. Light energy is converted to chemical energy. The above energy transformation can be seen in. Let's go through this light into chemical energy. Now when light in a torch, you all know most of the time in the torch, dry cells are used. So what type of energy is present in the dry cells, children? You all know that is chemical energy, right? So from the chemical energy, it is converted to electrical energy, right? So when light in a torch, what happens? Electrical energy is converted to light energy, right? Here, the question gives the other way around, light energy into chemical energy, right? So here from chemical energy to electrical energy to light energy, right? Number 2, photosynthesis by green plants. Isn't this correct, children? We'll just consider photosynthesis. You all know for the photosynthesis process, energy is provided by the sun, which means an essential factor of photosynthesis is sunlight. Without sunlight, photosynthesis would not take place. Right, children? Therefore, so what happens? Light energy is converted. Now, during the photosynthesis process, green plants produce food. What type of energy is contained in food, children? You all know that is chemical energy, right? So, during photosynthesis, when food is produced in plants using the sunlight, the light energy is converted to chemical energy. Light into chemical energy. So, the second answer is correct. But we need to read all 4 answers given, right? When light in a candle, candle is made up of wax. Wax is a type of fuel. All the types of fuel contains chemical energy. So when you light a candle, what happens? That chemical energy is converted to light energy. Because when you light the candle, the wax burns and you can see the light, okay? So therefore, chemical energy is converted to light energy, right? The last one, generating electricity by solar energy. There what happens? Light energy is converted to electrical energy. So what is the correct answer? The photosynthesis by green plants. This energy transformation can be seen in photosynthesis, right? Light energy of the sunlight is converted to chemical energy of food produced by the green plants, okay? Right. Number 2. A similar question. Electrical energy is converted to sound energy. An appliance in which the above energy transformation takes place is, let's see, electric fan. Electric fan, what happens when you switch on the fan? It starts rotating. So in that case, rotating means moving, kinetic energy. So electrical energy is converted to kinetic energy there, right? Mobile phone. So you all know that when using electrical energy, there's a battery in the mobile phone. Because of the battery, the mobile phone works. In that case, because of the battery, electrical energy is produced. You all know that it produces sound. It can convert it to sound energy. That is correct. Electric cooker, using the electrical energy, when electricity is supplied, the cooker gets heated up. Therefore, electrical energy is converted to heat energy there, right? Electric iron, it's the same. When you turn it on, what happens? Electrical energy is converted to heat energy, right? So, electrical energy to sound energy, that is the most correct answer is mobile phone, right? So, we'll underline that. Right, children? Okay, number 3. the unit of measuring energy is. What is the unit of measuring energy, children? That is joule, right? So ampere, joule, volts, watt. So ampere is used to measure the amount of electric current. Volts is used to measure the voltage of a circuit. And watt is used to measure the amount of work or the efficiency of work done. And finally, joule is the answer. Number 4. An instance where potential energy is not stored is. What is the meaning of potential energy? Potential energy means the type of energy stored in different types of objects based on their location or position and based on their shape or change of shape. Right, children? So let's see an instance where potential energy is not stored is. Number 1. A moving stone. What type of energy is contained in any moving object, children? That is known as kinetic energy, right? So moving stone contains basically kinetic energy, right? A stretched rubber band. So when you stretch a rubber band, right, what happens? Its shape changes, therefore it stores a certain type of energy. What is that? Potential energy, right? Water stored at a higher elevation, we already learned that in hydropower plants, water is stored at a higher elevation and it stores potential energy, right? So a wound spring, here what happens when you wind a spring, during winding you store potential energy, right? Therefore, a wound spring contains potential energy before it releases. Therefore, an instance where potential energy is not stored is, what is the instance? A moving stone. Right. Number 5. The energy transformation that takes place in photosynthesis is. Now again, we are discussing the same thing. Now even here, do you remember we discussed light energy is converted to chemical energy in photosynthesis. It's very easy now, right? Therefore, the energy transformation that takes place in photosynthesis is light energy into chemical energy. Chemical to light, heat to chemical, kinetic to chemical, light to chemical, right? So light energy to chemical energy. Number 6. Chemical energy is converted to light energy, the other way around of this, right? The above energy transformation can be seen when, let's see, generating electricity by a solar panel. What is the energy transformation takes place when electricity is generated by solar panel, children? There, sunlight is converted to electricity. Therefore, light energy into electrical energy, right? Lighting an electric bulb. There, what is the energy transformation? Electrical energy is converted to light energy, right? Electricity into light. Here, shooting a stone from a slingshot. What is a slingshot, children? You must have seen sometimes. Sometimes children play with these type of slingshots. These type of wooden part, right? This type of wooden part is taken and rubber belt is fixed here, right? This is known as a slingshot. So here you can stretch this rubber band to your side and you can place a stone and you can shoot it, right, to a distance. So when you stretch this rubber belt, what happens, children? Its shape changes and it stores potential energy, right, children? So if you want to shoot a stone with this slingshot, what you have to do? You have to place it somewhere here and then you have to stretch this band behind and then you have to release it. So then because of the potential energy, when you release it all of a sudden, that potential energy will release to kinetic energy, and because of the kinetic energy, this stone will move forwards, right? So what is the energy transformation takes place here? Potential energy is converted to kinetic energy. But here they ask chemical energy to light energy, right? The last one, light in a candle. So candle is made up of wax. Wax is a type of fuel. We discussed already, right? So here what happens when you light a candle? Because of the wax, because of chemical energy, light energy is given. Right, children? So this is the answer. Chemical to light energy. Light in a candle. Wax burns and light is produced. Therefore, chemical to light energy. Right. Number 7. When a bottle with a balloon fixed to its mouth is immersed in hot water, the balloon inflates. We did this activity. The energy that causes the balloon to inflate is, what is the reason, children? So now we will label this is hot water. Hot water. So here what happens because of the hot water. Now even though bottle looks empty, you all know that air present in the bottle. Right? So when you immerse this empty bottle in hot water, what happens? The air inside the bottle absorbs heat and the air expands. What is the meaning of expansion of air? During expansion, the volume of the air increases. Right? The volume of the air increases. So here the bottle is covered with the balloon. So the increased amount of air will go into the balloon and the balloon inflates because of that. Right, children? So the energy that causes the balloon to inflate, because of heat energy, the air expands. Because the air expands, the balloon inflates. Therefore, what is the basic energy that causes the balloon to inflate? Heat energy. Right? Kinetic energy, potential energy, thermal energy, chemical energy. Thermal energy means heat energy. Right? So the answer is thermal energy. Right, children? We will move on to the next. Right. Exercise number 2. Fill in the blanks with suitable words, right? Number 1. The ability to do work is known as. What do we need to do any work, children? That is energy, right? Sometimes to do hard work, we need a lot of energy. But for simple activities, simple work, we need only a little amount of energy. However, we need energy to do work. Therefore, the ability to do work is known as energy. Right. Deformation of things, which means change in the shape of the things. Melting, which means the solids turned into its liquid. Burning or combustion, and evaporation, which means liquids turned into its gas, right? Can be caused by what type of energy? Do you remember we did experiments to test this one, children, right? Do you remember when we heated the PVC pipe? You can bend it, right? Because a certain part melts and its shape changes. Okay, children? Melting, burning, evaporation, everything can be done by heat energy. Therefore, answer is heat energy. When lighting a firecracker, what energy is converted to sound energy? Firecrackers contain different chemical substances. Therefore, chemical energy is contained. That chemical energy is converted to sound energy, right? Therefore, chemical energy. Number 4. The energy contained in the water stored at a higher elevation is called, what is the type, children? Potential energy, right? Potential energy. Number 5. Potential energy and kinetic energy are commonly known as. Now, in the first part, we learned that kinetic energy and potential energy are together known as, what is the meaning, children? What is the name given? Mechanical energy, right? Potential energy and kinetic energy are commonly known as. They are, when we take them together, they are known as mechanical energy. Mechanical energy. Right? The ability to do work is known as energy. The formation of things, melting, burning, and evaporation can be caused by heat or thermal energy. When lighting a firecracker, chemical energy is converted to sound energy. The energy contained in the water stored at a higher elevation is called potential energy. Potential energy and kinetic energy are commonly known as mechanical energy, right? Right, the next one. We had right answers. Mention 3 forms of energy that you know. We know many types of or many forms of energy now. Shall we write some of them? We can write light energy, thermal energy, sound energy. Right? Light energy, thermal energy, sound energy. You can write other examples too, right? What is energy transformation? Now, so far we discussed one type of energy is converted to the other type when we do different activities, even with machines. This is known as energy transformation. We can't always use the same type of energy as it is. When we are using it, it will change into a different form, right? So this is known as energy transformation. So conversion of one form of energy into another form of energy is known as energy transformation, right? Let's write. The conversion of one form of energy into another form of energy energy transformation. Right? What is energy transformation? The conversion of one form of energy. We have to write that. Right. The conversion of one form of energy into another form of energy is called energy transformation. Right? We'll move on to the next. Exercise number 4. Complete the table given below. Now this is also very easy now. Okay? Because we did so many examples similar to this. Right? So here you have to write the main form of energy that made the equipment work. The equipment is given in the middle. Other forms of energy created, right? We already did these type of examples several times now. So main form of energy that made the equipment work. The first one is the light bulb. So you need electricity or electrical energy here. Electrical energy. What type of energy is created? Basically light energy and also heat energy. Light and heat. Light energy and heat energy. Next one is the television. Again, we need electrical energy to make it work. Electrical energy. So what type of energies are formed here? Sound energy, light energy, And you all know that any kind of electrical appliance, when we use it for a certain period of time, it gets heated up. Therefore, heat energy is also correct. Heat energy. Right, children? Next one. Equipment is microphone. What type of energy that made the equipment work? Now you all know that. Why do we use the microphone here? Microphone is used to amplify our voice, right? So when we talk to a crowd, you all know that our single voice is not enough. Therefore, we need to use a microphone like this. In that case, what type of energy is provided to the equipment? When we speak to the microphone, sound energy is given, right? So other forms of energy created using an electric current, this sound energy is converted to electricity. So using that electric current, it is amplified, increased, right? And given out as sound again, right? Therefore, what we have to provide, the type of energy that we have to provide is sound energy. And it will be converted to electrical energy. Electrical energy. Right, children? Solar panels. Solar panels, you all know it converts solar energy or light energy into electrical energy, right? So main form of energy that made the equipment work, solar panels won't work without sunlight. Therefore, light energy. And it produces electrical energy. Right? Electric fan, it works because of electrical energy. And it starts moving, which means it produces kinetic energy. And at the same time, sound energy is also produced, children. You all know that sound is also created when the equipment works, right? We'll write that. But the main form is electrical energy to kinetic energy, right? Electrical energy into kinetic energy and sound energy. The next one, waterfall. You all know that just before the water falls down. The upper part of the waterfall contains water with potential energy, right? So when it falls down, it converts to kinetic energy, right? So here potential energy and it is converted to kinetic energy. Right, children? There's another part as well. So what is this equipment? It is a water heater. You all can see inside this cup there's water. This water heater is inserted in the water, immersed in water, right? So water heater, it works because of electricity. And when it gets heated up because of electricity, therefore, electrical energy is converted to heat energy. Electrical energy is converted to heat energy. So what is this? This is a small circuit with a dry cell and an electric bulb. Here we will consider the dry cell part, children, because in the first example we already discussed about the electric bulb, right? Therefore we will consider this. So what type of energy? Now why do we use this dry cell? To generate electricity. In order to generate electricity, what should be there? Chemical substances, right? That is because of the chemical energy, electrical energy is converted. Therefore, what main form of energy that made the equipment work is chemical energy. Chemical energy. Is converted to electrical energy. This one, a small radio. So radio works because of electrical energy, right? So because of electrical energy, what are the forms of energy created? Sound energy, right? Basically sound energy, but sometimes if the radio has small bulbs, light energy is also created. And at the same time, after a little while, it will get heated up. Heat energy is also created, right? Electrical energy into sound energy mainly. Sometimes light energy too. Most of the radios, there are small bulbs. Light energy and heat energy. Right, children? And the last one. Right. A man is running. To run, you need energy. You need to burn food and then get energy. So someone is moving. Running is a type of movement. Running means kinetic energy. Where does this person get the energy from? By burning food. Food contains chemical energy, right? So chemical energy should be provided. Main form of energy that made the equipment, the person made run. Chemical energy. Other forms of energy created, basically kinetic energy, right? Chemical energy and kinetic energy because it's running. So all the moving objects contain kinetic energy, right? So we answered many questions under this part. So when you look at any type of equipment, I hope now you can realize what form of energy should be provided and what form of energy is created when we use the equipment. Right, children? So I hope this was very clear now. We'll move on to the next. Right. Exercise number 5. Write the energy transformations that take place in the following instances. I hope this was very, very easy for you all now because we did so many examples similar to this, right? So light in a bulb, let's write light in a bulb. Electrical energy is converted to light energy basically. You can even write light and heat energy both as well. But we will write the main energy transformation, okay? Light in a bulb, electrical energy. Electrical energy is converted to light energy. Number 2, operating an electric fan. Even before we did that one, again electrical energy too. Operating a fan means the fan starts to rotate, which means kinetic energy, moving, right? Electrical energy into kinetic energy. Next one, rotation of a dynamo. How does the dynamo rotate, children? Because of the energy provided by water and by the turbine, right? So rotation of the dynamo, when the dynamo rotates, it has kinetic energy. What type of energy is produced? Electrical energy, right? Okay. kinetic energy is converted to electrical energy. Electrical energy. Right? Next one. Winding up a stop clock. Winding up a stop clock, when you wind it up, you are providing potential energy. Right? Which means you have to use your kinetic energy and you are storing potential energy. When you are winding up, what happens? You have to move it. You have to rotate the key of the winding stop clock. Right? In that case, kinetic energy is used. So this kinetic energy, using the kinetic energy, when you wind up a spring of the stop clock, what happens? It stores potential energy. To store this potential energy, you have to rotate the key. Rotating means moving. Kinetic energy, right? So kinetic energy is converted to potential energy. Right? Number 5, rolling of a rock down a hill. When the rock is on the top of the hill, because of the location, it's at a higher elevation, it stores potential energy. Right? When it rolls down a hill, what happens as it's moving, that potential energy is converted to kinetic energy. Right, children? Therefore, potential energy is converted to kinetic energy. Right, children? So I hope this was clear, right? We'll move on to the next. Right. Exercise number 6. Briefly explain how to prove that heat has the ability to do work using a glass bottle, a balloon, and a hot water basin. Do you remember we did the same activity in the lab, right? Draw a label diagram. First of all, we will draw the label diagram. Right. So we'll draw we'll consider this is the hot water basin and this is hot water. And we have to take a glass bottle and you have to cover the mouth with a balloon. Right. Okay. And let's label the diagram now. This is the balloon, glass bottle, basin, hot water. Basin, hot water. Right, children? So how to do this activity? Now you have to prove that heat has the ability to do work using this setup, right? So what we have to do, we have to set the apparatus like this and we have to then immerse the glass bottle in hot water, right? So we will write the steps now. We will write the method first. Method 1, step 1. Fix the balloon to the glass bottle. Number 2, then immerse the bottle in hot water. Hot water. How can we continue writing this, children? Now you all know. Next we have to write the observation. Do you all remember the observation, children? When we immerse this glass bottle with the balloon fixed to its mouth, when we immerse it in hot water, what happens? After a little time, you saw that the balloon inflates. We will write that observation. Observation. When the bottle is immersed in hot water, the balloon inflates. Right. Now, how to prove that because of this observation? How to prove that heat can do work, children? Now, we all know when you immerse this glass bottle in hot water, the air inside the glass bottle gets heated up and air expands. Expansion of air means increase of volume of air. Due to expansion, the air volume increases. This increased amount of air goes into the balloon and that's why the balloon inflates. So this whole process is a type of work, right? So inflating the balloon because of expansion of gas in the bottle is a type of work, right? It's a type of work. How did it do this work, children? Because of heat. Just imagine if hot water was not there, will we be able to get the balloon inflated? No. The balloon inflates because of the expansion of air in the bottle. The air expands because of the absorption of heat, which means the whole process takes place because of heat or thermal energy, right? So because of the heat, work is done, which means you all know that the ability to do work is known as energy, right? So the work is done by the hot water, right? Therefore, the heat has a certain amount of energy in it. It's known as thermal energy, right? Let's write this. Conclusion. Due to the absorption of heat, the air expands. Expansion means volume increases. We'll write that too. Yeah, expands. Volume increases. Due to the absorption of heat, the air expands and the balloon inflates. This is a type of work. Energy is needed to do work. As the above work is done due to heat has, here we have to say, the ability to do work using a glass bottle. Heat has the ability to do work. Right. Okay. Conclusion. Due to the absorption of heat, the air expands, which means volume increases, and the balloon inflates. We have to write that, and the balloon inflates. And the balloon inflates. This is a type of work. Energy is needed to do work. Right? We'll write this. Energy is needed to do work. So what is the work done here? Due to the absorption of heat, air expands and the balloon inflates. This is a type of work. Energy is needed to do work. As the above work is done due to heat or done by heat, heat has the ability to do work. Or within brackets, we can write heat has energy. Heat has energy. Right, children? So when you are asked to explain, you have to write the steps with a label diagram too. Right? So I hope you understood this one. We'll move on to the next. Right. Exercise number 7. The structure of a hydropower station is given below. We'll study this one. You all can see here. This is the tank. This is the dam. And you all can see when you compare to the hydropower station, the tank is at a higher elevation. Okay? So you all can see this is the tunnel. So the water flows from the tank through the tunnel to this is the turbine. Right, children? This is the turbine. It is connected to the dynamo. And from the dynamo, you all can see electrical supply, the wires also there. Right? So what is the type of energy stored in the tank? The tank contains water. You all can see the tank is at a higher elevation or upper position. So you all know based on the position and based on the shape, certain objects store type of energy called potential energy. So what is the type of energy stored in the tank? Potential energy, right? Potential energy. Next one. What is the type of energy contained in water that flows through the tunnel? So when there's a small gate, when it opens, what happens? From the tank, the water flows through the tunnels up to turbine. So in flowing water, what type of energy is contained? Anything is moving. Any moving object contains kinetic energy. Right? So what is the type of energy contained in water that flows through the tunnel? Kinetic energy. Kinetic energy. Right? Next one. What is the energy contained in the rotating turbine? Rotating turbine, again, it's moving. So kinetic energy of water is transferred to the turbine. Right? Therefore, this is also kinetic energy. Right. Next one. What type of energy is transferred to the dynamo by the turbine? Now you all know in the electricity lesson we learned that the dynamo has a large magnet inside. Right? The magnet is connected to the axis. Now to the axis, the turbine is connected. So when the turbine rotates, it makes the axis of the dynamo also rotates, and thereby inside magnet also rotates. Right? So what type of energy is transferred to the dynamo by the turbine? When the turbine rotates, dynamo also rotates. You all know that dynamos generate electricity by moving or rotating. So inside the magnet rotates. Next to the magnet, a coil of wire is present. I hope you all remember. We learn about the bicycle dynamo, children. Remember? Bicycle dynamo is something like this. So outside we can't see the structure. So but inside, this type of magnet present, next to that a coil of wire present. Right? So this is the magnet. This is the coil of wire. So this cap-like part, lid-like part touches in contact with the bicycle tire. So when you ride the bicycle, this part rotates. So along with this part, this axis-like part also rotates because it is connected to the magnet. Magnet also rotates, right? When the magnet rotates, an electric current is generated in the coil of wire, right? So in the dynamo, what happens? What type of energy is transferred to the dynamo by the turbine? When turbine rotates, it has kinetic energy. That kinetic energy is provided to the dynamo. So the magnet also starts to rotate. Therefore, that is also kinetic energy, right? Kinetic energy. Right. Number 5. Name the type of energy induced in the coil of the dynamo due to its kinetic energy when it rotates. So when the dynamo, the magnet rotates, what type of energy is induced, produced in the coil of wire? This is known as the electrical energy. Because of the magnet, the movement of the magnet, coil of wire generates electricity. Right? So in the upper grades, you all are going to learn this process as electromagnetic induction. Right? So the type of energy induced in the coil of the dynamo due to its kinetic energy when it rotates. What is the energy? Electrical energy. Electrical energy. Right, children? The next one. Complete the flow chart below to show the overall transformation in a hydropower plant's electricity generation process. We all can start with the tank, where the tank contains potential energy, right? So potential energy and then the kinetic energy of water, that's step 2. Kinetic energy of turbine, step 3. Kinetic energy of dynamo, step 4. And the electrical energy, step 5, right? Here only 4 steps are given. Therefore, in between we will put 2 steps together. So we will start here. Potential energy of water converted to flowing water, kinetic energy. Kinetic energy of water. So we can put the kinetic energy of the turbine and the dynamo together here because only 4 steps are given. Kinetic energy of the turbine and the dynamo. Finally, what type of energy is generated? Electrical energy. Electrical energy. Right, children? So the potential energy of water is first converted to kinetic energy of water when the water flows from the tank to the turbine. And that kinetic energy is transferred to first to the turbine, then to the dynamo. So when the dynamo rotates, electrical energy is generated. Right, children? We'll move on to the next. Right. Write some functions performed by machines. So many machines we use in our day-to-day lives. You can write any function of different machines. We will write some of them. Right. We can write ironing clothes, using electric irons. Because in order to iron clothes, electric irons need to use electricity. So write some functions performed by machines using electricity. Most of the time we can use electric machines, right? We can use machines to grind grains, right? Grinding grains. Using electric grinders. What else? What are the other machines we do? Washing clothes. Using washing machines. Right? Washing clothes using washing machines. You can write many other examples too, right? What gives man the energy to do the work? How do we get energy to do our day-to-day work? By eating food. Therefore, what gives man the energy to do the work? Food. Right, children? Next one. Exercise number 9. Define what kinetic energy is. What is the meaning of kinetic energy, children? Kinetic energy is the type of energy that is contained in any moving object, right? That is called kinetic energy. The type of energy contained in or stored in, contained in moving object. Is called kinetic energy. Right? The type of energy contained in moving objects is called kinetic energy. Write examples for the things with kinetic energy. Many examples we know now, right? We can write flowing water, moving vehicle or moving car, a flying bird, a running child. Different other examples. Many examples you can write even before we wrote some examples, okay? A flowing water, moving car, a flying bird, they all contain kinetic energy, right? We'll move on to the next. Right, exercise number 10. Write some tasks that are done with the kinetic energy contained in the wind. You all know that the blowing wind contains, because the wind means moving air, right? The blowing wind contains type of energy, and because it's moving, that is known as kinetic energy. We can use the moving wind to do our work, day-to-day work. Do you remember even in the 4th lesson we learned that what are the instances that we can use the energy contained in the wind to do our work? What are the instances, children? You all know that in wind power plants, in wind power stations, the energy of the wind, the kinetic energy of the wind is used to generate electricity. Right, children? So they are using those huge turbines. We can generate electricity using the wind. Okay, the kinetic energy of the wind. What are the other instances? First, let's write some tasks that are done with the kinetic energy contained in the wind. Generating electricity. Generating electricity. Do you remember we learned that the farmers use the kinetic energy of the wind for winnowing paddy? What is the meaning of winnowing paddy? So to separate good paddy from the hollow paddy or like empty paddy, you need to use the wind. So in that case, when the paddy is dropped against the wind, what happens, children? Because of the wind, the empty paddy seeds are taken away with the wind and the good paddy will remain. This is known as winnowing paddy. We learned this in the 4th lesson. Winnowing paddy. We'll write one more example, children. So to dry clothes also we can use the kinetic energy of wind. But basically when drying clothes we need to use the heat energy of the sun. Right? Now let's say due to sun's heat, when you put your clothes in the clothes line, what happens? Due to sun's heat, the water present in these clothes will evaporate and come out. Evaporation means water or the liquid water turns into water vapor here. Right? So water vapor will remain outside of the clothes in the atmosphere. But if the environment is very windy, what happens? Because of the wind, this water vapor will carried away faster. So in that case, more and more water vapor can come out of the clothes faster. So that's why when the environment is sunny and windy, we can dry our clothes faster. Right, children? So basically we need sunlight in order to evaporate the water from the clothes. In that case, we can dry the clothes. But at the same time, along with the sunlight, if strong wind currents also present, what happens, children? Because of the wind, this water vapor that comes out of the clothes is carried away. So in that case, there's more space for more and more water vapor to come out of the clothes. And in that case, the clothes get dried faster. Right? So we will write that as well, to dry clothes. Right? So ancient people, they use the energy of the wind in windmills to grind grains. But nowadays, most of the time, we use electrical grinders. Okay, so you can look for some other examples and add more to the list. Right? Next one. Write the energy transformation that takes place when generating electricity using the energy contained in the wind. What is the energy transformation, children? The wind contains kinetic energy. It converts to electrical energy, right? So kinetic energy of the wind, kinetic energy is converted to electrical energy. Electrical energy. So they are actually because of the kinetic energy of the wind. In the wind power station, there are huge blades. That kinetic energy is provided to the blades. So the blades also start to rotate. So they are also kinetic energy. So as these blades, this huge turbine is connected to a dynamo, the dynamo also starts to rotate. Then it converts to the kinetic energy of the dynamo. Now when the dynamo rotates, electrical energy is generated. In that case, kinetic energy into electrical energy, right? Okay. Next one. What is potential energy? Now we all know the answer because we discussed this many times. Potential energy means the type of energy contained in different objects based on its change of location or change of position and because of its change of shape. Okay, let's write the type of energy the type of energy stored in objects, the type of energy stored in objects due to the change of position or the change of shape. Is called potential energy. Right, children? The type of energy stored in objects due to the change of position or the change of shape is called potential energy. So when we store something at a higher position, what happens, children? It stores more potential energy than that of the object that is stored at a lower position, right? And at the same time, because of the change of shape, for example, when we have a rubber band, when we stretch it, it stores more potential energy. When we stretch it more and more, it stores more potential energy, right? So write examples of the things that contain potential energy. So you all know in hydropower plants, the water that is stored at a higher elevation, right? Let's write water stored at a higher elevation. Higher elevation. Then a stretched band or stretched rubber band. Stretched rubber band. Then we'll write one more example. We can write a fruit on a tree. A fruit on a tree, right? Just before it falls down, when it is still fixed to the tree, it has potential energy because it's at a height, right? Water stored at a high elevation, a stretched rubber band or a stretched bowstring, right? A fruit on a tree, those type of examples you all can write, right? We'll move on to the next. What is energy transformation? Now earlier also we wrote the answer. So conversion of one form of energy into another form of energy is known as energy transformation. Let's write. The conversion of one form of energy into another form of energy is called energy transformation. Right, children? The conversion of one form of energy into another form of energy is called energy transformation, right? Next one. Write the energy transformation that takes place when generating electricity using the energy contained in flowing water. We all know now. So when the water is stored at a higher elevation or higher position, it contains potential energy. Potential energy. It is converted to the potential energy of water first, because when the water starts to flow, the potential energy is converted to the kinetic energy of water. So because of the kinetic energy of water, the turbine starts to rotate. Therefore, the kinetic energy of water converts to the kinetic energy of the turbine. So because of the rotation of the turbine, the dynamo also starts to rotate. Therefore, the kinetic energy of the turbine converts to the kinetic energy of dynamo. So when the dynamo rotates, it produces electricity. Therefore, the kinetic energy of dynamo converts to electrical energy. So we will write all the kinetic energies together. So kinetic energy. And finally, electrical energy or electricity. Electrical energy. Right? So write the energy transformation that takes place when generating electricity using the energy contained in flowing water, potential energy to kinetic energy to electrical energy. We'll move on to the next. Right. Exercise number 13. Number 1. Write two main forms of energy received by the earth from the sun. What are the two main forms of energy received from the sun? Light energy and heat energy, right? Light energy and heat energy. Light and heat. What form of energy does a candle contain? Now, candle is made of wax. Wax is a type of fuel. So, fuels contain chemical energy. Therefore, candle wax contains chemical energy, right? So, what form of energy does a candle contain? Chemical energy. Next one. Write the energy transformation that takes place when lighting a candle. So when you light a candle, this chemical energy is converted to light energy and also heat energy because candle provides heat as well, right? Therefore, chemical energy is converted to light energy. Can write it together, and heat energy. Or you can even write separately. Chemical energy into light energy and chemical energy into heat energy. That's also correct, right? So write the energy transformation that takes place when lighting a candle. Chemical energy is converted to light and heat energy, right? Okay. So this is the last exercise of this lesson, right? Write the energy transformation that takes place when using a dry cell. We did it even before. Dry cell contains chemical substances in it. So when you generate electricity using dry cells, chemical energy is converted to electrical energy, right? Let's write chemical energy into electrical energy. Electrical energy. Right. Number 2. What is the natural source of energy that provides heat energy to the entire world? What is the main natural source, children? The sun. So the light energy and heat energy is provided basically by the sun. So this light and heat energy provided by the sun is very, very important for the existence of life of the earth, right? Therefore, answer is the sun. Last question. Write some changes in substances due to heat or thermal energy. What are the changes? Let's write now. Do you remember we did some activities to study this, children? Do you remember? We used using heat energy. We held a PVC tube and we changed the shape of the PVC tube. This is known as deformation. Deformation or change in shape. Right. Then burning substances. What else, children? When we provide heat to water, water starts boiling and then water starts to evaporate. Boiling means liquid water turns into gaseous water, right? Evaporation. At the same time, because of heat, solids turns into its liquids. It's known as melting. Melting of substances. So during our activity, we studied these things. Right? Some changes in substances due to heat. The formation of things, burning, evaporation, melting of substances, all these things take place because of heat. Right, children? Now we have completed the entire lesson. So we did a lot of experiments under this lesson. Some of these experiments you all can even try at home. Right, children? So we answered a lot of questions. We did the questions given in the textbook and we did some extra questions as well. I hope you all have answered all the questions successfully. So when you wrote the answers, if you made any mistake, go through the lesson again and try to write the answers to the same question so that you can improve your knowledge.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.